Good morning. Hi, guys.
Hello.
Hi.
Hello, hello. I have quite important announcement about attendance. I received an email, and I don't think that I was the only one. I think it was sent to all professors in our department. It was an email from the head of Science, Math, Technology department, and probably he did that because he also received another email from the management of our college district about sending them names of students who do not actively participate our lectures. Unfortunately, we have very few names of these students who were absent quite many times when we conducted our virtual classes. At the same time, unfortunately, we have some of students who practically did not attend virtual classes. And again, it was not my idea. It was a request coming from my manager, and I already sent that information. This why, please be careful, because we conduct our classes during our regular schedule, which we had from the beginning of semester when we had normal classes. Besides that, I received an email yesterday from one of students in your class with the question about keeping the promise of dropping the lowest one quiz grade and one test grade, which is based on the number of absences. Your eligibility is based on the number of absences which you had for entire semester, including our virtual classes. Please keep this in your mind. Definitely, if it was promised to you in your syllabus, I will keep this promise. And at the end of our semester, when I have a full picture of your attendance, I will make this decision about your eligibility for dropping the lowest one quiz grade and one test grade, which we had in so-called class settings. It is not online quizzes or online homeworks. Please keep this in your mind, even though right now we conduct all our meetings and everything online. I think you understand what I'm talking about. If you have more questions, you definitely can address your questions to me via email, or send me an email and I can call you, because I have in database all your numbers, phone numbers, or send me, let's say, your number in your email, and I will call you in the time when you can talk to me about this. Now I'm going to check attendance, but before I do that, I will release information about pages in your textbook where you can find all required formulas for this material. Are you ready?
Yes.
Please write down, and while I check attendance, you can look at these formulas, and I really recommend you to make a list of these formulas or to do flashcards and systematically several times a day review that formulas. Again, this is an information about pages with formulas. I'm starting page 309, page 362,
Was that 50 or 60?
62, 362, page 365, page 367, page 382. I will briefly repeat again. So these are the following pages: 309, 362, 365, 367, 382. We actually have more formulas in regular trigonometry textbook, and I'm sure you covered more formulas, but at least these are the most important formulas which you have to know. Beside that, you need to know values of all trigonometric functions of quadrantal angles and reference angles like 30 degrees, 45 degrees, and 60 degrees. I mentioned them in degrees, but they can be provided in radians. Okay, please start looking at these formulas, and I'm going to call your names for attendance. Today is April 14th, and the following students should be in my class: Andrew.
Here.
Tima. Lorraine.
Here.
Lynn.
Here.
Juanita. Iran.
Here.
Gabriel.
Here.
Divina. Kabi. Chantal.
Here.
Ricardo. Hochito. Gongsi.
Here.
Kyle.
Here.
Matthew. Julian.
Here.
Nathan.
Here.
Alejandro.
Here.
Okay. Now, I will show you that last problem which we solved in our class. Is it true that it is the last one? Is it correct?
Yes.
Okay. And if you remember, I introduced you with the European method, which can simplify the process. And definitely, I will be using this more to show you what can be done with this method. Now you have two options how we can start the problem. Do you have any particular problem in your mind which you like to ask me about, or you let me start?
Go ahead.
Excuse me?
You can start.
I can start. Okay. On page number 284, on the bottom, you have problems from 26 to 31. And I'm going to read here what we have to do. In problems from 26 to 31, find the exact coordinates of the point at the given angle on the circle of radius 5, centered at the origin. So it is not a unit trigonometric circle because radius is equal to 5 units. That center is at the origin, which means that, yes, it is a trigonometric circle. The only radius is not 1, so which means it is not a unit trigonometric circle. I will remind you something, and I gave you that formulas a long time ago. I mean, maybe at the end of the previous week when we started trigonometry. I said long time ago, that's too long time ago, but it is on the previous, let's say, at the end of the previous week. So this is what I'm going to write down. Let's say P, I just use capital P because word point starts with P. Point is P with coordinates X and Y. The radius of this circle is 5 units. Center, C, center is at the origin. The point is 0, 0. Which means it is a trigonometric circle. If we have, I'm going to sketch quite ugly, probably circle, because here I'm not going to show many things on this circle. And let's say point is P right here, and coordinates are X and Y, and radius is equal to 5. And my angle is theta. So my circle more looks as a potato or ugly orange, but let's pretend that it is a perfect circle. So, and what about this angle? Why did I choose, let's say, point P in the third quadrant? Because I am planning to work right now with problem number 31. 31 has theta equals to 315 degrees. 315 degrees. So practically again, theta belongs to the third quadrant. Theta belongs to the third quadrant. First, I'm going to write the formulas connecting coordinates of that point P with that angle. According to the definitions of trigonometric functions in any trigonometric circle, X coordinate is affiliated with the cosine of that angle. And look what I wrote down. X over R is cosine theta. At the same time, Y over R is sine theta. If you multiply these two formulas, both sides by R, you are getting X equals R times cosine theta, while Y equals R times sine theta. So which means, because we know the value of R, we just need to find values of cosine theta and sine theta, where theta is equal to 350 degrees. We need to multiply these values by R, and we can get X and Y values, which are coordinates of point P. So which means indirectly, we actually are asked to find values of sine theta and cosine theta when theta is 350 degrees, 15 degrees. Is it clear to everyone?
Yes. Yeah.
So let's start our process of looking for these missing values. I I traditionally like to start with value of sine because sine is the first trigonometric function in the list of trigonometric functions. So, step 1, sine of 315 degrees. 315 degrees is the angle from the fourth quadrant. Oh, I said third quadrant. I really apologize. I looked at the different spot. Oh my God, 225. I really apologize. I need to change the position of that point P. Point P is right here. So it is right here in the fourth quadrant. Accidentally, I looked at the closest value, 225. Oh my God, I just had my trigonometry lecture, 2 hours lecture. My brain is not functioning. Please, can you switch? You need to erase that. P is having new position, the fourth quadrant, please. I really apologize. I did not do that purposely. I accidentally looked at 225, which is close to that problem. So, why I am mentioning that fourth quadrant? Because fourth quadrant contains angles between 270 degrees and 360 degrees. If we think about 315 degrees, is it actually equal to 270 degrees plus 45 degrees? Or from the other hand, it is 360 degrees minus 45 degrees.
Yes.
You can choose one of these options. You have 2 versions, but you just need to deal with one, or 270 degrees plus 45 degrees, or 360 degrees minus 45 degrees. Which one would you like to use?
360.
Okay, so write it down that it is sine of parenthesis 360 degrees minus 300. To reach 315, I need to subtract 45 degrees. So 360 degrees minus 45 degrees. And now let's apply our European rule. 360 degrees minus 45 is actually 315 degrees. Is it in the fourth quadrant?
Yeah. Yes.
In the fourth quadrant, sine is positive or negative?
Negative.
Negative.
Write down minus. In parentheses, you have quadrantal angle of 360 degrees. Is it vertical or horizontal?
Horizontal.
Horizontal.
Should I keep the same function or I need to switch to another one?
Keep
Another
same.
one. Keep or switch?
Keep it.
Keep it. So it will be sine of 45 degrees with minus. So it is minus sine of 45 degrees. That definitely everyone in this class should know the value of the sine of 45 degrees. By the way, what is the value?
Square root of 2/2.
Accepted. So it is negative square root of 2/2 because the sign had minus in front. So this is the value of the sine of 315 degrees. But just before that, we wrote down that if you know the value of sine, you can find y coordinates. So y equals r, which is 5, times sine of 315 degrees, which is multiplying 5 by this negative square root of 2/2, I'm getting negative 5 square root of 2/2, So y coordinate is negative 5 square root of 2 over 2. Did you understand how we reach that answer?
Yes.
Yeah.
In absolutely same manner, we can find x coordinate. For that, we will be using cosine of 315 degrees. Definitely, nobody can dictate you which method to use, number 1 or number 2. I'm talking about using new presentation for 315 degrees. If you use 360 degrees minus 45 for 315 degrees in the first step, looking for sine of 315 degrees, nobody can force you to, against your will, to use the same thing. Definitely, if you like to choose cosine 315 degrees like cosine of 270 degrees plus 45, it is your right, you can do that. But let's be logical. If you already used, let's say in the first step, 360 degrees minus 45 degrees, maybe it is quite logical to use the same thing and for cosine of that angle.
Yes.
What do you think?
I agree.
In other words, I am asking you, would you like to use again 360 degrees minus 45 degrees, or you like to use 270 degrees plus 45 degrees? I don't mind.
360.
360.
Okay, in this case, rewrite this in the same manner. Cosine of 360 degrees minus 45 degrees. And we will use the same method. Don't forget, it is actually about 315 degrees. Is it still the same fourth quadrant?
Yes.
Yes.
In the fourth quadrant, cosine is positive or negative?
Positive.
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 Positive. Do you understand that because we used 360 degrees, which is a horizontal quadrantal angle, we will keep the same function, which is cosine. Yes?
Yes.
Yes.
Which will be cosine of 360 degrees minus 45 degrees, actually equal to positive cosine of 45 degrees. And cosine of positive cosine of 45 degrees is positive square root of 2 over 2. And now, knowing the value of cosine, I'm going to write the formula for x coordinate, which is r times cosine of the angle, which means 5 times cosine of 315 degrees. I'm replacing cosine of 315 degrees by its value, and I am getting very easily that case, which after simplification gives me positive 5 square root of 2 over 2. And I probably would not stop here, because if we have separate lines for x coordinate, for y coordinate, if I were you, I would actually write finally that this point is the point where I'm listing as a pair x and y coordinates. As a final answer, this will be quite elegant and logical end of the process. Where I wrote both coordinates and x coordinate and y coordinate as a pair. of coordinates. Do you understand how to solve problems from this spot?
Yeah.
Yes.
Yes.
Okay. With your permission, can I move to the next spot?
Yes.
Yes.
In the next spot, we see something different because now angles are coming in the form, different form. Before that, we dealt with angles given in degrees. Now they are coming in radians. Right now, on this side, I'm going to write formulas which can help you to convert radians into degrees or degrees into radians. What should you remember as a magic sentence? That 180 degrees is equivalent of pi radians. I all the time tell my students to memorize that piece. 180 degrees equal to pi in radians. Up to you to write that abbreviation for radians or not. You can simply actually write that it is 180 degrees equal to pi. When you do not see anything next to the pi, it means in radians. But you cannot ignore that small tiny circle next to 180, because if you do not write it down, it means 180 radians. But if it is a degree, you are obligated to write this symbol, because 180 degrees is not equal to 180 radians. From this sentence, we can get both relationship between measure in degrees and radians and between radians and degrees. Why? Because if I look at 180 degrees, I can treat 180 degrees as 180 as a number multiplied by 1 degree. Is it correct?
Yes.
In this case, if you treat this as 180 as a number multiplied by 1 degree, from the boxed relationship, you can divide both sides by 180 just as a number without degree, and you will get 1 degree equals pi over 180 in radians. This is the formula which can help you to convert degree into radians. 1 degree is equivalent of pi over 180 in radians. In absolutely same manner, you can treat pi in the first box as number pi, which is approximately 3.14 times 1 radian. So part B, pi radians can be treated like number pi times 1 radian. In this case, you can work again with the first box where 180 degrees equal to pi radians and divide both sides by pi, which can let you solve this first box equation in the first box for 1 radian. Doing that, you are getting that 1 radian equals, if you divide again the top box by pi as a number, which is approximately 3.14, you are getting the following relationship. In this case, don't forget about the symbol of degree. And this is that box. Which you have. I will solve some problems converting, again, degrees into radians, radians in degree, to remind you that you did solve many of these problems in your trigonometry course. So I am going to right now grab one of problems from this very short spot, 32, 33, and 34. Just choose one of these problems and I will solve it for you. Which one? 32, 33, or 34? Ladies and gentlemen, I ask you to choose one of problems out of three. Which
34.
one? 34. Okay. Number 34. Let me copy the problem. Cosine 11 pi over 6. What should we do here? Find the exact values without calculator. And this is the problem. Cosine of 11 pi over 6. 11 pi over 6 is quite strange looking angle, but I will work a little bit with that fraction, 11 pi over 6. On the bottom of this fraction, we have 6. 11 is not divisible by 6. But can you tell me about the number close to 11, which is divisible by 6 without any problem? Which number very close to 11 is divisible by 6?
12.
12.
Can I say that 11 pi can be written like 12 pi minus 1 pi?
Yeah.
Yes.
So let's do that. And again, you used this also. It is same 11 pi over 6 only written in different form. I wrote down 12 pi minus pi over 6 instead of 11 pi over 6. And I'm going to simplify right now this fraction in parentheses. So it will be cosine, definitely. 12 pi over 6, is it 2 pi?
Yes.
Yes.
And don't forget, there is minus pi also. So this is what I'm having right now. Cosine of 2 pi minus pi over 6, which replaced 11 pi over 6. And now I'm going to apply this rule. Pi over 6, is it equivalent of 30 degrees?
Yeah.
360 minus 30, is it the angle from the fourth quadrant?
Yes.
In the fourth quadrant, cosine is positive or negative?
Positive.
Positive. So in this parenthesis, do you have a vertical quadrantal angle or horizontal?
Horizontal.
Horizontal, because it is 2 pi, it is horizontal. Should I keep cosine or I need to switch to sine?
Keep it.
Keep it. So it will be cosine of pi over 6. Excellent. So practically, to answer this question right now, getting the answer for entire problem, you are having value of cosine of pi over 6, which you need to know the value for. What would be the answer here? What is the value of cosine of pi over 6 or cosine of 30 degrees? I'm waiting.
Square root of 3 over 2.
Yes, it is square root of 3 over 2. And this is your answer for this problem. Done. Okay. Now I would like to show the application of these formulas, converting degrees into radians in degrees, having one problem for each of these cases. And these are here also right on the top of the same page. Okay. In exercises 1 through 8, determine the radian measure of the angles. Can you please choose one only problem from this part, from 1 through 8? Please. Can you do that in timely manner? Because I try to solve more problems because we have 5 minutes left, guys. Which one? 1 through 8.
5.
Did you say 5?
Yeah.
Excellent. Okay. Number 5. What should we do? We have 150 degrees. And we need to convert this into radians. Look what I'm going to do. I will write this like 150 times 1 degree. 1 degree. Can I?
Yeah.
Yes.
So grab the value of 1 degree, which you have in the box in part A. So it will be 150 times, and according to that box, it is pi over 180, which is value for 1 degree. And simplify that. 150 and 180, are they both divisible by 30?
Yes.
Yes.
Reduce. So it will be 5 here, 6 here, 5 instead of 150, 6 instead of 180, and your answer is 5 pi over 6. It is up to you to write next to that radians or not. If you do not write anything, it is in radians. We're done. This is the answer. Can you see how easy it is? Now, can you please choose one problem from 9 to 13?
9.
Okay. The only thing it is, so is it 7 halves of pi?
Yes.
Okay. 7 halves of pi. If you do not see anything next to that, it means it is 7 halves of pi in radians. Look what I'm going to do. I will write that it is 7 halves of pi as a number multiplied by 1 radian. And now I can look at the box in part B right here. And this is the formula for 1 radian. So, and look what I'm going to do. I will keep 7 halves of pi, and I will multiply by 180 over pi. Don't forget to write the degree sign, because now it is very important not to skip that degree symbol. And simplify. We can now cancel both pi's. They're gone. And in 7 halves, can you see 2 in denominator? You can cancel these 2 with 180. So it will be 90 and 1. 90 instead of 180 and 1 instead of 2. So basically you are left with 7 which should be multiplied by 90. If you multiply 7 by 90, is it 630 degrees?
Yes.
So this is your answer. It is 630 degrees. So I will show the second method for the same problem 9. This is so-called shortcut, but you can use second method only if you have in your reading measure symbol of pi. Because if it is just a number, let's say -2 or 4.27, you cannot use that shortcut method. But here you can. Let me show you how. So second method. Do we know that pi is equivalent of 180 degrees?
Yes.
Yes.
So, and look what I did. I replaced pi by its equal value, 180 degrees. But again, you can do that only if you have pi symbol in your measure of the angle. So 2 and 180, we cancel by 2, and we are getting same 630 degrees. What can be more elegant than that? Very short cut. But if you have a different reading measure, let's say number, let's say which one? Let's say 18, which is 0.75. And it is problem number 18. I choose that. It is 0.75. And it is not having any pi in this measure. It is just 0.75, which means 0.75 radians. What should you do? Because I am planning to cancel later, if it is possible, I am going to write instead of 0.75, 3/4. Can I?
Yes.
Yes.
This is what I did. And I'm writing that it is times 1 radian. And I'm going to use first method, which I demonstrated in part 9, because I cannot use here shortcut. So it will be 3/4, and instead of 1 radian, I'm writing 180 over pi in degrees. Okay, and if we are looking for the exact answer, you cannot approximate. So, but you can cancel 4 and 180. Is 180 divisible by 4, ladies and gentlemen?
Yes.
Okay, if you divide 180 by 4, what do you get? Is it 45?
Yes. Yes.
Guys?
Yes.
Now,
Yeah.
if you multiply 3 by 45, what do you get? 3 times 40,
135.
is it 120 times 550? Is it 135?
Yes.
Yes.
So 135 over pi in degrees. This is your exact answer. That when your answer looks quite strange like that, you can approximate. Let's approximate. So practically, grab your calculator, turn this on, and simply divide 135 by pi. Your pi is located above that button which has that corner for powers. So you are using second button and that corner button. This will look exactly like 135 divided by pi, and push enter. And let's say we are approximating to the nearest 100. So it will be approximately 42.97 degrees. I will box both answers, exact answer and approximated answer right here, if you like to convert. Approximating. So I showed you both type of conversions. This is how we convert, again, degrees into radians and radians in degrees. And if you need to convert radians in degrees, if you have in your measure pi symbol in the radian measure, you definitely can use the shortcut, which is very elegant. If you do not have pi symbol, you are limited. You can use just traditional method. So this about how to convert. I assume that you will be very serious about formulas, that you will be prepared for tomorrow's class, because tomorrow I will be working with identities. Maybe I even will start equations, and I will do many things. And in our activities, we will be actively using formulas. Is it clear to everyone?
Yes.
You have already another section open. Did you have an opportunity to see that new section open
Yes.
in
Yeah.
homework? And it is, again, all this material is not a new material. So practically you are welcome to solve any problem from these homework assignments. With your permission, can I end my today's lecture?
Yeah.
Yes.
And again, as I do that all the time, I will, as soon as I'm done, I will rest a little bit. And after that, I will record this on YouTube and will send you a link. Okay? Okay.
Sounds good.
Have a nice, beautiful day and stay well, please. And I will see you tomorrow.
You too.
Goodbye. Goodbye.
Okay.
Bye.
Bye-bye.